Hello everyone. In this video we are going to solve a problem on finding the resultant of forces from FL Singer. So this is the problem given. The block shown in the figure is acted on by its weight W equals to 400 Newton, a horizontal force F equals to 600 Newton and the pressure P exerted by the inclined plane. The resultant R of these forces is parallel to the inclination. Determine the P and R and does the block move up or down the inclination. So they have given this figure. From the figure we can see that this block is lying on this inclined plane we can call it, which is making an inclination of 30 degrees. On this block there are two forces are acting. One is vertical force because of its weight, that is 400 Newton, and there is a horizontal force applied on the block with a magnitude of 600 Newton. In addition to that, there is a pressure P is exerted by this inclined plane or ground, which is making an inclination of 45 degrees with respect to the vertical axis. In addition to this, they have mentioned that resultant R is also acting, which is parallel to the inclination. So this is the resultant R which is parallel to the inclination. They haven't mentioned what is the direction. We need to figure out whether the resultant is causing the block to move up or down to the inclination. So this problem can be solved using multiple ways. Either I can fix my x and y axis perfectly horizontal and vertical. I can resolve the body's forces as per that, the resultant as well as P, and I can solve it. But the easier way is the reference axis, that is x and y axis, I can rotate it parallel to the ground, okay, and we can solve it. So here you can see that I have plotted reference axis. Reference x-axis is parallel to the ground and reference y-axis is perpendicular to the ground. Okay. So when I see this is a perfectly horizontal x-axis and this is perfectly a horizontal y-axis. So a force is acting vertically 400 Newton here and horizontally 600 Newton here. So this is with respect to the perfect x and y axis. Now what I'm doing is the whole x and y axis I'm rotating by 30 degrees. Since the ground is having an inclination of 30 degrees, what I'm doing, this references axis I'm rotating it 30 degrees. So I have rotated the x axis and y axis the inclination of 30 degrees. Why 30 degrees is since with the horizontal plane the inclined plane is making an inclination of 30 degrees. That means x and y axes are also making inclination with respect to horizontal and vertical. Right? So once what is the necessity to make this rotation is to find out the inclination with respect to inclination of the forces with respect to this rotated reference axis. If I am able to find out the inclination, then the resolution of the forces will be easy, and from those forces I can easily find out my resultant of forces. So this 600 Newton, it is making an inclination of 30 degrees with respect to my rotated x-axis, and as you can see here also 400 Newton is there, which is making an inclination of 30 degrees with respect to the rotated y-axis. So I got these two inclination. Next is we have additional force which is P acting on the body, which is making an inclination of 45 degrees. Right? So as we can see, these opposite inclinations are same 30 degrees. Now with respect to rotated y-axis, what will be my the inclination? It is nothing but 45 degrees minus 30. That will give me 15 degrees. Now I got all these inclinations. In addition to that, they have mentioned that resultant is parallel to the inclined plane. That means it is the inclination will be 0. So let us resolve the forces for each and every force so that we get the component with respect to rotated x and y axis. So I have initially first force is 400 Newton. If I resolve it, I'll get 400 cos 30 degrees with respect to y axis and 400 sin 30 degrees with respect to rotated x axis. Similarly, I have a 600 Newton, which is making inclination of 30 degrees with respect to rotated x axis. So if I resolve it, I'll get a 600 sine 30 degrees with respect to y rotated y axis and 600 cos 30 degrees with respect to rotated x axis. Similarly, I have this P pressure P, which is making inclination of 45 degrees. As I said, the rest uh, the relative angle between the rotated y axis and this force P is 15 degrees. So when I resolve this, I am getting an x component as P sine 15 and y rotated y component as P cos 15. So as you can see the directions, since this 400 Newton is acting downwards, but with the rotated body, it is acting in a downward direction. Now what will be the component? Since it is acting inward to this origin point, both the x and y components will be acting inwards. The direction will be inwards. Similarly, for 600 Newton, for this as well, it is acting inwards to the origin. Hence, the components of x and y as well, it is acting inwards. Similarly, for the P as well, it is also acting inwards to the origin. So, the components are P and sine theta cos theta components will also be inward. So, once I have got all these components, now I need to find out what is my resultant. To find out the resultant, what they have given is they have given the resultant force here, which is we are assumed that it is going upward direction, which is parallel to the rotated x axis. So if it is parallel, that means the inclination will be 0. So if I want to find out the x and y components, that will give me summation of fx as well as summation of fy. So when I resolved it, so it will be cos 0 degrees. Cos 0 is nothing but 1, so it is giving me r. Similarly, the y component r into sine 0. So this sine 0 is 0. We will be getting only one horizontal component. So first what I will do is I will just find out summation of fx. So as you can see along the x axis, whatever the components are there, I am just summing it. So I have 600 cos 30 degrees, which is acting rightward, in right direction. So it will be positive. So 600 cos 30 degrees. And the other two forces, 400 sine 30 degrees and P sine 15 degrees is acting left side. So those will be negative. So I have added this value. So by simplifying this, I will be getting this R equals to 519.6 minus 200 minus 0.259. So I am keeping this one as equation 1. Now, similarly, I need to do it for the y component. So as we know that summation fy is 0, so all the components which we are getting along the y direction, I am just summing it up. So 600 sine 30 as well as 400 cos 30 is acting downwards to the reference axis. So those two components will be negative. As well, the P cos theta, P cos 15 degrees is acting upward direction. So it will be positive. So simplifying this as summation fy is 0, so I'll be getting P value as 669.10. So I'm substituting this P value in equation 1. From that, I'll be getting R value as 146. Hope this problem is clear. So we'll see you in the next session. Thank you.